Welcome to myprojectbazaar.com. Now I am going to discuss about title for this project. Our project title is Detection and Classification of Fruit Diseases. Now I am going to discuss about the abstract for this process. In this process, we are developing a fruit disease classification, identification of fruit disease classification. The manual identification of the detected thing from the given data, which is very time consumption. We are proposing an approaches which uses the neural network to identifying the defects in the fruits. Clustering is used to segmenting the affected the part in the fruit image. If detect is identification means the detection region is segmented. The color images is converted into LAP color space. The k-means clustering is applied to segmenting the image. Then finally, the detector, the item is identified by identifying the defected cluster. Here we using the k-means clustering is the segmentation algorithm. After the segmentation, we take the features for the input image. On the segmented image, the features are extracted from the image using shape feature, texture feature. A local binary pattern is a texture feature, and CNN features is extracting the algorithm. The features are extracted for the input image and all the images in the database. The extracted features values are passed into the neural network classifier. The neural network classifier the image into the normal or a defected. The extracted test features and the trained features are the passed to the multi-SVM classifier in order to finding the types of defects in the cluster. After the classification, we finding the performance of the classifier is calculated. Here we calculating the accuracy, sensitivity, specificity, precision and the recalls are calculated in this process. The accuracy and the sensitivity specificity is improved in comparing with an existing system. Now I am going to explain about a flow diagram for this process. First one is an image acquisition stage. Here we taking one input image from the dataset folder. After we taking the input image, we gives the pre-processing stage. The pre-processing is unnecessary noise in the image were eliminated. An unnecessary noise referred to the unwanted pixels in the image. Pre-processing method uses small labeling of the pixel in an input image to get a new brightness values in the output image. Such a pre-processing operations are also called as a filtration. Local pre-processing method can be divided into two groups according to the goal of the pre-processing. Smoothing, suppressing the noise or other small in the image equivalent to the suppressing of the high frequency in the frequency domain. Unfortunately, smoothing or blurring and sharp edges that are pure input of the information images. Next one is an image segmentation. If the images are classified as abnormal image, the infected region is segmented. K means algorithm is used to segmenting the image. K means K nearest neighbor algorithm. The input color images of the fruit is transformed from the RGB to LAP color space. The defected region are grouped into the single cluster. The images is segmented into the clusters based on the pixel values changing in the image. Next one is a feature extraction. The features are extracted using the shape feature. LBP feature extraction and the CNN feature extraction is an algorithm for we used. The same features like area and the diameter for the image features are extracted in the process. LBP is combined with the histogram of the oriented gradient HOG descriptor. It improving the detection performance considerably on the some datasets due to its discriminative power and computationally simplicity. LBP texture operator has become a popular approaches in the various application. Finally, we calculating the CNN features for the segmentation image and then comparing the shape feature LBP features values and CNN features and considering as a test features for the query image. After that, we chaining the whole dataset images for these feature extraction methods. Finally, we classifying the input image. In this classification process, in machine learning and support vector machines are supervised learning models with the associated learning algorithm. that analyzing the data used for the classification and regression analysis. Given a set of training example, each marked as a belonging to one or other of the two categories. The SVM training algorithm building a model that assigning a new example to the one category or other, making it a non-probabilistic binary linear classification. The SVM model is represented for the example as a point in the space, mapped so that the example of the separated categories are divided by the clear gap that is as wide as possible. Name a new example or then mapped into that same space and predicted to the belonging to a category based on which side of the gap they fall. Finally, we calculating the performance analysis. The accuracy, sensitivity and specificity of the classifier is measured. The accuracy represents the efficiency of the process. The sensitivity shows how the algorithm given the correct classification. The specificity shows how the algorithm rejected the wrongly classification result. We designed a spatial consistency constraining in the graphical model to improving the detection performance. Now I am going to explain about output for this process. First, open the MATLAB and go to the coding location and select current folder and click main.m file. Right click the main file to see the run option. So now I am going to click the run button to run our main.tcl file. In that main.tcl file have one dataset, and the dataset have 30 images, 30 JPG images. So in that Apple images are affected and non-affected images are in the dataset folder. Now I am going to select any one input image. Now I am select 18.jpg image and the process is running. In this process, we first get one input image, then we pre-processing the image. In that process, pre-processing is at two stages. First one is a resize and another one is a filtering image. Now the process is running. Now I am going to select input image. Next one is a pre-processing image. It is resized image. The image resizing is used to fixing the row and column. Next one is a filtering image. The unwanted noises in the images are removed in this process. Next one is a channel separation image. So red channel, green channel and the blue channel of the Apple images is separated here. After the channel separation, we clustering the image. So affected and the non-region image, affected and non-affected regions are displayed here. Next one is a feature extraction. In this process, we extracting a three type of feature. First one is a save feature. So area and the diameter of the value is displayed. Next one is an LPP feature. A texture features is getting and displayed in the table. CNN features are extracted and displayed in the CNN table. And test feature, and test feature is nothing but it is a combination of save feature, LBP and CNN. So and the train feature, so the train feature is repeated the dataset folder images and getting all the test images and saved into the train feature name. And we are finally identifying the disease identified. So if the disease identified means further we finding the which type of disease is affected in the input image. So in that input image is affected the apple rod. Next one is a performance measures. That accuracy, sensitivity, specificity of the process is displayed in the table manner and displayed in the graph manner. Thank you for listening. Our demo is complete. Thank you.